Hello. In the last video, we learned about experiments and how scientists gather findings. In this video, we will observe an experiment together and track our own data and findings. In order to track your data, you'll need your warming experiment chart or a chart that's similar. In the last video, we set up two different jars that each represented the Earth's atmosphere. Jar A was open with a thermometer inside, and jar B was sealed with clear plastic wrap and a rubber band with a thermometer inside. As a reminder, jar A represents the Earth's atmosphere in its most basic form. That means we don't do anything to change what it is. It is our control in the experiment. Do you remember what a control is? That's right. A control in a scientific experiment is the thing that scientists do not change so they can compare results. Jar B also represents the Earth's atmosphere in this experiment, but it is covered at the top with clear plastic wrap and a rubber band. This change in the jar is called the independent variable. As you know, an independent variable is a thing changed by a scientist to measure differences in an experiment. Now that we have both jars set up, we are ready to begin the experiment. Our dependent variable, or the thing we went to observe or measure, is the temperature of the jars. To track the temperature of the jars, there's a thermometer in each jar. Are you ready? Okay, let's get started. First, we need to take the baseline, or beginning temperature of both jars. Both jars are 23 degrees Celsius, which is room temperature. On your warming experiment chart, begin to track your data. Fill in 0 minutes for the time and 23 degrees Celsius for the temperature of both jars. Also, mark any observations or notes you have. It should look something like this. Now that we have our first temperature recorded, let's place both jars in direct sunlight and wait to see what happens. We will record the temperatures of the jars every 5 minutes for 30 minutes. Okay, 5 minutes is up. Jar A and jar B's temperatures are both still 23 degrees Celsius. Track this on your warming experiment chart and take any observations or notes you have. "10 minutes is up. Jar A's temperature is still at 23 degrees Celsius, and jar B's temperature is now at 24 degrees Celsius. Track this on your warming experiment chart. Halfway point, 15 minutes is up. After 15 minutes, jar A's temperature is still 23 degrees Celsius. However, jar B's temperature is now 25 degrees Celsius. Why do you think jar B's temperature is increasing faster than jar A? Write a few observations or notes on your warming experiment chart. "20 minutes is up. Jar A is finally starting to get warmer and is 24 degrees Celsius. Jar B stayed the same at 25 degrees Celsius. Track this on your warming experiment chart. "25 minutes is up. Jar A's temperature stayed the same at 24 degrees Celsius, and jar B's temperature increased a little more to reach 26 degrees Celsius. Track this on your warming experiment chart. Okay, 30 minutes is up. This is the last data we will collect for the experiment. Jar A's final temperature is 24 degrees Celsius, and jar B's final temperature is 27 degrees Celsius. As you look at your data, remember that jar A represented the Earth's atmosphere in its most basic form, and jar B represented the Earth's atmosphere, but was covered at the top with clear plastic wrap and a rubber band. So let's think about our results. How did the independent variable of the clear plastic wrap on the top of jar B change its temperature? Was it warmer or colder than jar A? What do you think this represents? Think about all of these questions and write them in the discussion board following this video.